All right, we are going to go ahead and get started. There we go. Evan, you can see that okay? Awesome. All right, so let's get through this. Today we're going to be going over shape optimization, and this is the fourth module. The next module is going to be going basically into the final project and then just having work time for any miscellaneous things on the project that you will have to complete. This is the attendance QR code. I'm gonna leave that up for a second. And real quick before we start, from now on, we are going to be starting to get a little bit more strict with the late assignments. There have been a few too many requests and we can't be granting those all the time. So we're going to start to be more strict with those late assignments and just start not accepting them from after Tuesday at 11:59 p.m. from when the time for assignments or the due date for assignments is set. So moving on, start class. All right, so why shape optimization? So okay. So why shape optimization? Basically, there's many factors within shape optimization that are important to manufacturing, also to prototyping. The main one is to reduce material. Shape optimization basically, like the name says, optimizes the shape to have the least amount of mass possible as defined by the user while trying to keep the structural integrity and the strength of that model or part. And like I said, reducing material is not that important for prototyping. However, it's crucial for mass production as the cheaper the part is, the better for the company or whoever is producing it. Reducing manufacturing time is also another factor of shape optimization, especially when it comes to either 3D printing or additive manufacturing. Doing this can not only reduce material, but also reduce the time the part needs to cool and or print, which is really important for manufacturing and mass production things such as, sorry, lost my train of thought. Yeah, it's faster to produce. You can produce more. It's better that way. And then the final point of why we use shape optimization is to improve productivity. We want more that we can get for our raw materials that we have. So for example, filament, you want to be able to produce more with less material, and this is a way to do that. So how does it work? Basically, a 3D model is subject to a specific study in Fusion 360. The one we're using static stress, as we've been learning about that. And then this step basically allows the computer to understand the behavior of the component under the specified conditions that will be used in the real life scenario. And as such, the constraints and loads should represent the real life scenario you are trying to model with this simulation. The mesh must be as accurate as you possibly can get it to be because there's a strong influence in this, or this influences the shape optimization operation very strongly. And this goes back to last week and being able to get that convergence and get the best model you can get for the allotted time or the amount of resources you can use with the operation. And then a mesh is generated based on the weak and strong points of the 3D model or part. And this will be shown in the results tab, which I'll go over when we do the example. And basically, this mesh represents the useful portion of the component. There's color coding with it, which means that you'll be able to see what part is strong, what part is not, and what parts of the model you need to improve. And then from this, the original model can be modified. You'll be able to sketch on top of the actual mesh that's created from the shape optimization, and then you can either make a new part or change the previous part you had and rerun the simulation to see if the shape optimization was correct. So going to the steps of this. There we go. So going to the steps of this. Sorry, I lost my meeting controls for some reason. Hold on. There we go. All right. So going into the steps of this, the first step of this is to create a new study. I'm going to quickly go over the slide, then I'll hop on Fusion 360, and that way you'll be able to see what's going on. So the first step is to create a new study, and you're going to select the shape optimization instead of the static stress study that we have been doing previously. You're going to assign the materials if you have not done previously in the design to aluminum 6061, which we're using for this class. And then very similarly to the previous assignments, you're going to specify the constraints and loads. You're going to fix the interface of the bigger hole and then apply a load of 10,000 newtons with an 180-degree X angle to the smaller hole. So I'm going to go ahead and do that. Just delete this real quick. Make sure you can see my screen. So from here, you'll be able to see this will pop up when you open the simulations tab. And as you can see here, static stress, which is what we've been doing. We're going to go ahead and select this one right here, shape optimization. Then you're going to go ahead and hit create study. Awesome. So from that, you'll be able to see that we need to create the loads and constraints, right? So we're going to go ahead and go here, constrain like we've done before, set the load to 10,000 newtons, and then set the X angle to 180 degrees. Go ahead and do that. Next step is going to be to generate the mesh, and we're actually going to modify the mesh very slightly. We're going to set the mesh to a 1% model-based size, and then we're going to go into the advanced settings and set the max turn angle on curves to 10 degrees. Going to go ahead and hit OK, and it'll prompt us to generate. You probably got this last week. You can go ahead and click yes. It just means it's going to take longer to run simulation. But then from this, you can go ahead and right-click the mesh, generate the mesh, as we've done before. Give it a second for it to do that. Awesome. So then from there, we're going to need to actually define the optimization settings that we're going to want. For your assignment, this is going to be the thing you're going to mainly modify and change, but you can either go through here to shape optimization criteria, or, so I'll do that again real slow. You just go up to this top right here and shape optimization criteria, the third one on the list. Or you can go into your tree here and go to shape optimization settings and click this little pencil icon, or just click the drop down and you'll see the actual things you can change. I'm going to go ahead and click this because that's just how I do it. And you'll see two things on here. You'll see the target mass. So this is how much mass we want from the original model to still be present in the shape in the results section of the shape optimization study. We're going to go ahead and leave that at 30, but in your assignment, you're going to be able to play around with this value and change it to get different results. And then the other thing that you can change is the stiffness of the actual material. We're going to go ahead and leave that with maximize. Now, there's one more thing you can actually change in shape optimization. Actually, there's a lot of things, but one more thing that's pretty important is you can go here to this little plus and left click it, and you'll be able to see the minimum member size popped up. There's right here, the minimum member size is basically when running the shape optimization study, a kind of variable that the computer basically says you cannot have a part that is less than this size, a width, either that being a width, a length, or a height, or a radius. And basically it just allows the part to keep certain structural integrity portions that you may need. For right now, this doesn't matter, so I'm going to delete it, but it should be set to 2.256 by default. If yours is not, please do set it to that. I'm just going to go ahead and hit delete on that though for now. And then you can go ahead here and just click OK. And from there, your shape optimization settings are set. See, as you can see here, this is basically optional. So then from now, we're going to go ahead and click the pre-check, make sure we're all okay. As you can see, we are. Then we're going to go ahead and hit solve on this. So doing shaped optimization actually uses cloud credits. As you can see here, it popped up, took a second to load, 3 cloud credits. To do the assignments for week 4 and week 5, or any shaped optimization study, as well as a couple other types of studies, you will need these cloud credits. To be honest, I don't know exactly what they are, but I know that you need to pay for them, and I know that Purdue pays for them. So please use your Purdue account on Fusion 360 when you are running these studies. As usual, you're just going to go ahead and hit solve study. and it'll run that. I'm just gonna give it time to run that.
Sorry.
Good. Here, I can put it the. Okay, we're just running a simulation right now, so we're just waiting, but. If you want the attendance QR code, I'll put that back up there. It might take like 10 minutes probably.
Shape optimization takes some time.
Yeah. Did the QR code work? Okay, good. See.
Shape optimization is basically reducing your QT here. When we did our studies, second to third week, we got 50 safety factors. So like we apply that same rule, but say you want to get more efficient, right? You want to use less material, so that's basically what shape optimization is. Here are some advantages of doing shape optimization. So So I'm then walking through how to set up the shape configuration. Here's the first setting material. Yep. 60.
I just realized I forgot to change the study material, so I'm gonna rerun this. Oh boy. Could have sworn the model was set at 1161. That's all right. Just go ahead and hit resolve on this bad boy.
So after that, we'll create the same constraints and same rules of feet. And then what I mean by that is the 10,000 course. Yep. Yep, so now you fit there. So this is when, oh, okay, actually still exactly the same class feet, so you're gonna edit your version. Yeah, your model is at 7%. And your advanced setting, in advanced settings, when you can external contours. Once you got it, yeah. So is when it starts to get a bit different. So, rather than just trying to shape optimization, so there's two ways you can get this. One is right here, the other one is through this drop down and shape optimization. So, yes, yeah, so for this one, it's be separated into target and is there, your step is there, and you can add this to the as under that. Yes, it's right there. So it's optional, so you can no, but yeah, there, and that's fine. Now as you can see, the check set you get so all you gotta do is run it. So yeah, it's all.
What is the minimum member size?
So the minimum member size creates like a lower boundary of basically. So when you shape optimize, I'll show you what it looks like. There you go. So this is what happens. So the system telling you like, okay, you can basically get rid of all this, right? So that minimum member size tells the system, well, I don't want it to go below this certain in the width, like the height. So that's that. It just gives like a lower boundary measure basically. So yeah, and yes, this is exactly what I wanted to go through. So you do not have enough Gov credit to run it. I had the exact same issue. Can you get information? Why is it there? Okay, sorry.
So I just need to sign somewhere.
No, so I had the exact same issue like 30 minutes ago, and they just gave me another option for it. Wait, let me get my mouse. What did I do? Yes, there we go. Okay, so as you can see, you have two accounts here. Well, technically one, but you see in this one, which is your personal one, you have 0, but in the education one, you're unlimited. So you just want to change both of the education. Yes. There you go.
Why does it not do
All right, am I good to go?
Yeah, go.
Yeah, all right. So if you guys are trying to do your shape optimizations, it's very likely that you'll run into an issue that says that you don't have enough cloud credits to run it. Maybe.
Yeah, go for it.
So how you guys would fix this is, can I finish this off?
Yeah.
So you go to solve here, and from show, you want to click on cloud credit costs and balances. And then you want to switch your account to education here on simulation tasks and on generative design tasks. So by default, you will have your individual one selected and you'll need to switch to education. So again, let me repeat that. Before solving your study, you want to click on this drop down menu. Make sure you click this cloud credit costs and balances. And then you want to go to your account here and switch your account to use to education. Because as you can see, the education one has unlimited, while your personal one will have a certain number. And yeah, besides that, I think you should be good to go. I'm going to pass it back to Bernardo.
Awesome. All right. So go back to results here. So, okay. So from here, you can see that the results tab, this results tab should pop up. You can just hit X on that, but this is what will come up. And as you can see here, I'm going to just rotate this around. It basically thinned up the part very, very much. The red portions are basically the portions of that need the most integrity in the part, so they're not being removed. And then with this, you can also change the slider, either the upper or the lower bound, and you can see what it would be like if you had less or more taken away from the part. So right here, you see the mass ratio and the actual approximate mass. So if I were to slide this target down, you can see that it's increasing the actual percentage of material that would be left on the part. So you can go all the way to 100. That's just our original part, or the target value, which we had set was, it was about 30. So it goes up really close to it. But you could do say 40%, 35%, 40%, everything along that way. And then with that, I'm going to set this back to, I think it was like this. Okay. You can just get close if you mess with the slider. And then you can also change the upper bound to see how, to remove the more strong parts if you want to see weaker parts in the part. Along with this, like I said, there's a percent down here that you can see of the actual approximate mass or not the approximate, the actual mass percentage that's left over from the original part and the approximate mass with that. So from this, we're going to want to modify our original model to fit the actual shape up the optimized model, because as one can see here with the high safety factors we had from last week, we don't actually need this much, that much material on the part for it to be able to withstand that force. So what we're going to do is we're going to go into the results tools here into this drop down, and we're going to go ahead and click promote, and that'll pop this up right here. So it's this mesh that's created can basically be transferred to either the existing model that you use to run the study or a new model, which you can then modify from there. So what we're going to do is we're going to actually select, we're going to go ahead and select the existing simulation model, which is the one that we just ran right here. And then we're going to go ahead and select simulation 1. So as you can see, it kind of superimposed or inside of it, the mesh that it actually generated. And now from this, we are currently in a simplifying tool. And from this, you're able to either simplify the part, or you can also hit finish simplify and do it through the actual design tab. However, it's much easier to do it through this because it's already right here. So what we're going to do is we're going to go ahead and create a sketch. And I'm just going to select this top plane right here. And you can see the mesh right there. And what I'm going to do is I'm basically going to go ahead and create a shape that resembles the mesh very closely. Oh, sorry about that. And this doesn't need to be exact when you do it for your assignment. It can vary a little bit. That's okay. We just want to see that you guys are getting the general idea of how to do this. So I'm going to go ahead and create a triangle there. And then I'm going to go as close as possible to this, maybe right here. And just do an edge there. Fusion. All right, I'm actually gonna delete this circle. Then I'm gonna create an arc here. And then I'm gonna repeat this up here as well. Get as close to there as possible. And I'm just gonna go ahead and close this shape. I'm going pretty quickly through this, but again, if you guys need help, just let one of us know. So I did a half there, and then I'm simply just going to create a construction line down the middle. Then I'll mirror these entities. Mirror down the middle. Okay. Then I'm going to go ahead and click Finish Sketch, and then I'll go to Extrude right here. And as you can see, I can just select the shapes I want to be removed. And then I'm going to go ahead and change the operation. Instead of new body, I'm just going to hit Cut. And then I'm going to change the extension type to just through all. And I'm going to flip that direction. So then I'll go ahead and hit OK on this extrude operation. And as you can see, it removed the material from the outside. The mesh is still there. You can kind of see it generally resembles that shape. Obviously, we would do some cleaning up. We'd probably fillet these sides. Maybe we would try to get this circle to be more accurate. But for the purposes of this right now, this is okay. I also did this previously, and it looks a little bit different than this. Just as close as you can get to it is fine. For your assignments, we would prefer that you guys have kind of a more clean circle on the outside. I just did this right here for lecture example. So you're going to go ahead and click Finish Simplify. And Finish Results. And as you can see, you're going to get that warning pop up. That's basically saying that your new model has not been run through the simulation. So your results would be different if you were to rerun it right now. But what we're actually going to do is we're going to go ahead and hit Study and create a new study. We're just going to do another static stress study. And then we're going to do the exact same thing as before, constrain the inner face of the big circle, and then apply a load of 10,000 newtons with 180 degrees on the face of the inner circle. Go ahead and make sure that our mesh is still set up the same, 1% with 10 degrees on the max turn angle on the curves. Go ahead and generate that mesh as well. We're going to go ahead and hit solve on this. Take a second to think. Go. Just going to let that run. While that runs, I can show you guys the example I did previously. So as you can see here, I've already rerun this with the optimized shape and the sketch and the removal of the material that I did before. I removed too much material. Actually, this is I believe it's a 20% calculation. As you can see, the minimum safety factor is below 1, so that means this part would fail. In this place, in this spot right here where it's red, right here on this edge, as well as on the inner hole of this face right here. Let's see what that's doing. Let that run real quick. Any questions? I know I went really quick through that, so.
I'm still joining.
Okay, yeah. everyone a second to get up to speed.
Okay, so could you do the lines you just extrude the form?
Yeah. Go ahead and extrude. Or, sorry. Oh, okay, wait. So you need to do. When you sketch, you need to sketch the part that you're gonna move. So you sketch like that inner circle, that the black one.
Remove the-
Yeah, so you're gonna wanna sketch from the big outer one. Yeah.
it looking? Alright, can you walk me through sketch?
Sure.
Oh,
So.
okay. Okay. And the issue now is that it's on. Oh, I see. Is it because it's like merged that your line is also,
Like part of the line is selected.
yeah. Okay, yeah, that works. Do that. Okay, and then now I think you should have solid.
Should I do this?
Did you change it to a construction line?
You can leave that.
Yeah.
Let me get a sketch.
Well, let's see where it goes.
Hit control to do it. Okay, now I finish first. Then the operations change it to do extent
Oh,
type, yeah,
sure.
operations cost. And then the extent type is. So what you want to hit. If you rotate it. You're gonna want to hit this one. Maybe you hit this. There we go. And then we just, we get the finish simplifier. You go to finish results. And then you go to study. And then we just did a static stress study on it with the same
Right, where's this?
parameters.
This isn't supposed to be.
Yeah, you can't go on body.
If you go back to, your first step. And then the results again.
Wait, do you wanna hold off and do that for 1 second? I'm gonna run through the rest of this since it's just looking at the results of that static stress study. And then just quickly going over the assignment and then we can go back and redo it. So, yeah, moving forward from that really quick, we basically, when you rerun the static stress analysis, you should get something like this. If you remove too much material or you extrude cut too much, you may get a safety factor below 1, which is not good. This was the one we just did. This was the one I did. Sorry, my screen controls are in the way. This was the one I did beforehand. And then when I did the class, this was the one I did. As you can see, this one was above 1. Mainly due to the fact that I did not remove as much material. And then I also filleted some of these things, which, like we have said a couple of times, can definitely change the way force is applied on those corners. So then from there, that's basically what shape optimization is. you can do it multiple times if you feel that the part has too high of a safety factor after you use shape optimization, or you could simply go back and change that mass factor that's left over to something lower than what you had previously. But really quick for the assignment for this week, it's only 12 screenshots. It's so the 30% one you have already done in lecture today. And then the 40 and 20% are basically just changing that mass ratio when you run the shape optimization initially. And then what you're going to do is you're going to basically optimize the shape using that mesh that's created. You're going to go ahead, sketch, remove, do the cut extrude, and then you're going to run the static stress for the same with the same parameters as before and get the screenshots for those. It should be a total of 12. Then I'll head back to this in 1 second. Just going over the total list of assignments here. These are basically modules 2, 3, and 4 assignments. I'm just going to leave this up for a second. If anyone needs this, if you're watching the video, obviously you can just pause right here. But if you need it in class or on the Zoom, just let me know and I can come back to it. I'm going to leave it at the assignment submission link QR code, which will also put this up on Slack as a link after the class. So yeah, now you just have time to work on your assignments. Let us know if you have any questions. I just realized I forgot to show one quick thing. So when you're doing the shape optimization and you are going through your I don't know if I can go back from here. When you're going through your basically you're creating your mesh on the top right here, there will be on that drop down with the extrude and everything else like that. There will also be an option to do other features if you click that drop down, such as fillet and things like that. That's the part I forgot to show, but it would be in this results section right here. I'm actually going to rerun it and pull it up just so it's on the recording and you guys can see it. But yes. Okay, so basically just going back to how I did that, you can basically from the new study, you can just go here and on the drop down, you go back into the simplify mode. And then from here, you can go to the create and you can see you get all the different options you would normally get. And then on modify, you also get all the normal options you get. So you can do a fillet or a chamfer wherever you'd like. For example, right here, I can do a fillet here and here, maybe say 5 millimeters. And then you can go ahead and just hit finish simplify. And obviously you'd have to, I've already run this study and I just changed the model. So you'd have to rerun the static stress study, but you would just go ahead and do that after you do that. So yeah.
Just
yeah.
sure, week 5, like.
Yeah, sorry, just a quick addition. I realized this said 12. This said 12. It's actually supposed to say 9 screenshots. So for the assignment, the 30% one was the one we did in lecture. You'll get the 3 screenshots of each simulation, the displacement, the stress as bond misses, and then the safety factor for that. And then you'll do it again for the 40 and 20%, basically running through what we did again. So yeah.